good morning, everyone. Thank you very much for this introduction. So my presentation, I go a little bit more on the feed processing part. And that's interesting because it really resonates a little bit from Mr. Joseph yesterday presentation, where he really mentioned that the point is not to have more animals or even more farms, but to use what we already have in a more efficient, in a better way, with better feed conversion for the animals. So that's what I'm going to tackle a little bit during this presentation. So I'm going to some key factors and variables in the feed mill. That's where I'm going to spend a little bit more time, because that's my area of expertise. Then just some touches on digestibility management, and then just the closing remarks, okay? So as we know, or we should be moving more as a more efficient way of using, or for the animal feed conversion. So it's not just looking at the feed conversion itself, but how the animals are using this energy, and how to be have the energy more, better used by the animal. The same thing for the hyper-efficient extraction. So how to better use the ingredients that we have available, as we just saw, even using some alternative ingredient, or not alternative, but a kind of a novelty ingredient, which is still sorghum. And of course, looking for the feed mill part. So sometimes we don't, when I visit, and I visit quite a few feed mills around the globe, unfortunately none yet in Kenya, but looking forward for that for sure. But we see some misusage of what they have already available in the feed mill plant, right? So maybe that's why we need to tackle and work to have a better usage of that equipment. And the focus is, we need to have clear in mind that the focus is the animal performance, right? That's what we need, especially when we're talking about integration system, where the animals are in a closed system. That makes even more important for the production than even in a commercial feed mill. And then just like the market pressure, as we saw yesterday as well during the introduction remarks, that all the wars coming in, and availability and weather, climate change, etc. The feed mill chain, so of course the impacts of the processing on that animal performance. And of course, the other parts, which is health, environment, and management. I just want to also mention a little quick summary, or really quick remark, comparing the both swine and poultry systems. Those are the main productions. Of course, I know here, or at least I found out yesterday, that the ruminants are really important as well in Kenya. But looking more on the monogastric side, those are the two most important, most produced globally. And most of the times, the same feed mill have to produce the feed for the both animals, or the both species. But we need to remember, or to have in mind, that they have a quite different digestive system, where the animal, the poultry, the birds, have like the gizzard, which is really an important pacemaker for the digestive system, for the absorption of the nutrients. And required quite a coarse particle size. Compared to the swine is a little bit more similar to our digestive system, where we need to have a little bit more finer particle size. But as I mentioned, sometimes we have the same feed mill producing the same the feed for these two different species, and they require different characteristics, different feed quality overall. Okay, so. This is just some baselines that I found out. For broilers, the feed conversion, the industry baseline is around 1.5, 1.6 almost, where we should be looking or optimizing to 1.4. For nursery pigs, so the gain, average daily gain of weight, 420 grams a day. That's the trend, or that's the nowadays trend or baseline. And then the lookout, or the forecast should be for 510 grams. And the grower finished feed, swine, sorry, the carcass yield, efficiency, around 76 should be the next level. So for broilers, the pellet quality and additives are very important. And where for the nursery, for the small pigs, the acidifiers, especially on that transition period, the young age, the acidifiers make a really important aspect for the piglets. Here, looking some of information I also found online, especially looking on the African reality, where the pressure cost, the biggest, as again, that's what I mentioned yesterday. The presentation from Mr. Joseph really resonated a lot on my presentation today because exactly matched with what I was going to present today. So the raw material really have a huge toll on the cost of production looking into the African market. Then the energy, quality claims, but especially downtime also, it plays a significant market. So that means sometimes maybe lack of maintenance, preventive maintenance, some things that is putting down the production capacity from the feed mills. So the feed cost, probably most of you know, 60 or to 70% is related to the feed cost of animal production. Raw material variability high, and then operation expectation, more with less. Again, like they mentioned yesterday, it's really not building more feed mills, of course. When it's needed, is needed. But maybe we're not producing or being efficient with what we already have available. The animal, the same thing, the conversion. Maybe we're not being as efficient on the feed conversion rate, so we need to produce more feed for that animal instead of really looking into the characteristics of the feed, the quality of the feed, to make sure that the animal has what the animal needs for better feed conversion or productivity, okay? So just to summarize this part, everything is integrated, right? So it's not one part only, it's not looking through the process, it's not only looking on the feed mill processing, it's not only looking for the animal digestibility or the management, where they really everything is interconnected, right? So everything needs to be aligned, everything needs to be working together to really bring that feed efficiency, animal performance improvement to the end results. So now, going a little bit more on my area of expertise, my passion is the feed mill. So I've been working almost 15 years already in the feed industry, from quality control to operations. So this is really what really brings, of course, I'm not going through all the steps. That's not enough time for us today. But I'll be focusing especially on the grinding, conditioning, pelleting, which is the top three factors looking into the feed milling efficiency or milling production, and especially the impact of this for the animal behavior. So grinding, of course, is looking for the particle size that the animal required. Mixing, having sure that we are mixing properly, that everything is according distributed throughout all that batch. Conditioning, of course, it's important for pellet quality, for some digestibility point, for some animal pellet quality improvements. Pelleting, just to make that a little bit better, to stabilize the feed form, to make sure that the animal is not picking and selecting the feed. So the pellet quality is really important. And of course, cooling to close the gap. So I brought the two main systems when we were talking about grinding. So one is the hammer mill, is the most common, probably is the one that most of you have in your plant, and the roller mill. The biggest advantage of the hammer mill is the speed, is the throughput, is the capacity, so we can really produce quite a lot feed or mesh with this equipment, but the biggest disadvantage is the variation on the particle size. So when you're talking about the variability in the mixing point, we need to make sure that we don't have too much, the particle size are not too different between them, or that could cause some segregation. And the hammer mill, it kind of tends to increase a little bit that particle size differentiation, but is the one that we use the most, is the one that is most used in the industry. Roller mill, it's really good for some uniform particle size to make sure that you are reducing that variability, but the capacity of roller mill is quite smaller compared to the hammer mill. Especially when we are talking about layers, breeders, some manufacturers, some producers, sorry, they really prefer to use the roller mill, especially because of that. You can work with a coarser particle size. You can have a particle size that's a little bit more appropriate for the birds, for the breeders, the layers, and without a huge variation. So some companies, some enterprises use the roller mill when they are working with layers and breeders. So this is just a graph that summarizes a little bit the differentiation. So as you can see, the particle size, so the dotted line here is the hammer mill. So it has quite fine particle size on the extreme and also on the coarse part as well. Where the roller mill, it tends to be a little bit more centralized, the particle size distribution, and then have the D50, or the average of the particle size, right in the middle, which brings a better, like I said, a better distribution of particle size and a better quality. So that brings some advantage, especially when you're talking about breeders and broilers, breeders and layers, sorry. The same here. So this graph is just the distribution. The same thing, the hammer mill tends to have a peak on the particle size, but some distribution, some gap, lower distribution, more centralized, where the roller mill has a little bit more, a better distribution overall the particle size. So that brings a little bit better particle size distribution, and with that, better animal usage, especially when you're talking with about birds, okay? The broiler, so the broiler, as I mentioned, they like around 800, 900 micrometers for particle size. That really brings some improvements on the digestibility. For layers, even higher, because the layers, usually they are not pelleted feeds, as we just saw the presentation. So for layers, they use mesh, so you can work with a coarser particle size once it's not going to go through a pellet mill. So you can work with a coarser particle size, sorry, which brings and supports not only the gizzard function, but also the length of the consumption of that feed by the animal, which is interesting for this kind of species. And then for swine, of course, between 500 and 700 micrometers. Okay, so this is just a literary review, and here is from my master, where I worked with different particle size. As we can see, as we increase the particle size, in this case I was working with soybean meal. As we increase the particle size, we increase the energy, metabolical energy from that feed, from that study. So that really shows the importance of particle size, especially for birds, right? For broilers in this case. And here is also a review from Amara that also show that impact on feed conversion when you have coarser particle size, especially with corn, and then the gizzard size or the gizzard development when you also work with a coarser particle size. So this is really just to prove the importance of particle size in the feed meal, in the feed production. So again, sometimes it's not producing more, it's producing better. It's producing targeted to the species that you are working with or producing for. So that really shows that sometimes just small changes in the feed meal, some adjustments in the particle size, in the hammers and the screens, etc., you can already have some benefits on your animal performance without having to buy a new hammer meal, a new feed meal, etc. So this is just summarize that really summarize the digestibility gain, the capacity on kilowatt hour, operational robustness. On that, of course, looking into the feed meal part. Now, more on the conditioning, as I mentioned, so I'll just go over those 2-3 points. So conditioning, the main target for temperature on the conditioning pelleting process is between 75 to 85 degrees. Of course, there's some, for piglets, quite low, lower that temperature because of the milk products that we add to the feed. But in general, for poultry and swine, grower swines, the range is between 75 to 85 degrees. The moisture of the feed after the conditioner around 15 to 17. I like to really target 16, just in the middle, to get a better cooking process, a better starch gelatinization capacity in the mesh, which will reflect in better pellet quality. So just a phrase, so the steam softness, the moisture lubricate. So, and steam and moisture are different. That's one point that I want to make clear when we are talking. Steam is really to increase the heat, is really to cook. Of course, the steam will bring some moisture because steam is moisture, is water, is boiled water, right? In a simple way of saying. But the main reason for steam is temperature. Moisture is something that we need to correct in the mixer, even before getting to the conditioner, because the conditioner will have a capacity, a limited capacity of increase or of adding that moisture through the steam. So steam really in the conditioner is to cook. The moisture we need to correct into the mixer to make sure that the feed is already with the correct moisture before it reaches the conditioner. This just shows the importance of the temperature and time for pelleting quality. So retention time on this yellow-orange graph here. So the temperature was kept consistent, and we increased the retention time, and the pellet quality didn't increase significantly. So what means that really the temperature, because that's what the next graph will show, but the temperature doesn't really the retention time doesn't make a huge difference. It helps, but really what's more important is really the conditioning temperature. So from 82 to 88 degrees, we also increase 5 points on PDI or pellet quality. And this other graph here is also the second part of my master work, where I worked with different temperatures that show also some improvement as we go to 75, 80 degrees. We increase also the metabolic energy consumption from the animal. So that really show that also there's a benefit on the temperature, not only for PDI, for pellet quality, but for animal also performance, for energy consumption from the animal. So that really also shows some improvements there. Then, of course, we have the 3 important factors for pellet quality, which is temperature, which I mentioned, around 80 degrees, moisture, and time. Okay, so those 3 factors really support, really helps when we are talking about pellet quality and conditioning process, right? There is another one, which is pressure, but doesn't really play a role in the pelleting process, more on the extrusion. Also, it's important for pellet quality or PDI. So these show the starch granules with different temperatures. As we can see, from 80 to 90 to 95, we have a more swollen, more integrated starch granules as we increase the temperature. So the temperature really helps also the starch gelatinization. But for that, we need to have the proper moisture. Just the heat won't make that effect. Also, the starch needs the water, the moisture, to really gelatinize, to really swollen the starch. Okay. So the pelleting process is more than just a feed form. So it really supports the starch gelatinization, which helps with pellet quality, but also some digestibility. It will reduce the ingredient selection, so the bird won't be able to be selecting different ingredients. We'll concentrate on the pellet quality, on the pellet particles, sorry. Improve flowability and handling, of course, and reduce the pathogenal contamination because of the temperature. So pellet quality, it will result in more intake, right? So the animal will spend less time selecting or trying to select the ingredient. The animal will spend less time going to the feeder. So that really is also some improvement on the energy usage from the animal. So it's important to have good pellet quality. This is just a model of a pellet mill which has 2 conditioners and is really just to show how big these equipments can get, up to 3 conditioners sometimes, or other times some retentioners. So those are the main equipments that really support the pellet quality process. So PDI durability. So this is really, it tells you how it holds the pellet integrity throughout the entire process of transportation until reaching the feeder. Percentage of the fines, that's really a loss of nutrient, not a loss of nutrient, but nutrient segregation. So that really can affect the animal performance. Hardness is really important when you're talking about swine, especially for piglets. The hardness of the feed can be a trick point, right? So the animal can reject if the feed is too hard. And visual, that's more for the swine, not so much for broilers. But also it really makes attractive to also the owners, right? Getting a bag with a feed that's fully pelleted brings more attention, brings more like a quality appeal to the buyer than compared to a feed that has a lot of dust, a lot of fines in the bags, right? And just 1 point, durability is different from hardness, okay? One is really how it will be durable, the pellet throughout the process, and hardness is how it really is hard to break the pellet by the animal. This is just the importance of moisture. As we increase the moisture up to the 15, 16 points, it brings the pellet quality to the maximum and the pellet milk capacity as well. So that's just to reinforce that importance of the correct moisture when you're talking for conditioning and pellet quality and pellet productivity. Again, making more with what we already have, right? That's the main message. It's really being more efficient. It's really being used the resource that we already have in a better way. Of course, there is a limit of sometimes we reach that limit even being efficient, and that's where we need to invest. But we need to make sure that what we already have at home, that we have available to us, is being used in a proper way. So the hidden losses between mixer and feeder, so moisture loss, of course, during the grinding process and cooler. Final generations, if the pellet mill, the conditioning process is not properly adjusted, that will, if the nutrient degradation, that's more when you have excess heat. 1 point of excess heat, for example, is during the pelleting process, as the feed goes through the die. If the feed is not properly lubricated, conditioned, we can have a high temperature through friction, and that can bring some damage. So sometimes we visit a feed mill where we saw some pellets, like a darker color pellets. That's like a Maillard reaction, and that cause, of course, a nutrient degradation. The animal won't be able to use that nutrient. And some segregation in the case of poor pellet quality. So this shows the importance of pellet quality for FCR, for feed conversion. So as finer the pellet, worse is the feed conversion rate. So 40% can give you 1.68 points of feed conversion. When you have a premium pellet, I'm not going to even the extreme because it's too much, but even if you'll be able to have only 10% of fines, that will already bring to a feed conversion rate quite interesting of 1.48. So just digestibility, also just to bring the importance, so the starch gelatinization, as I mentioned, that's important to have the moisture temperature to really create this starch gelatinization, which will improve the binding and of course improve the digestibility of that starch. The protein denaturation, so that can also impact on the usage. So on my master, I didn't bring the information here, but also we saw some improvement on the protein usage of by the animal, just with that different temperatures that we work during the trial. And of course, fiber structure change as we go through the conditioning and pelleting process. That will bring beneficial improvement for the animal. So again, just to summarize the particle structure, so that really is important for especially broiler. The feed form to attend, the pelleting crumble to attend the characteristic of that animal. or that specific phase as well. So for example, for chicks, for the small birds, of course we need to crumble the feed, the pellet, to make sure that the animal can access that feed. Process sensitivity, so that's sometimes, like as I mentioned, if you are using, for example, some milk replacer ingredients, some milk byproducts, we need to make sure that we are adjusting the process because it is sensitive to some temperatures in the process. So this also, just mentioning the organic acids in this case, just because of it helps also on it protects the animal gut, so that will help with the feed safety part, but also will activate, you boost the pepsin activation, so also can have an impact on improving some of the digestibility, but especially the feed safety part from health part for the animal. And then just to finalize my last part, so that's everything. That's just to really say that everything needs to work together. It's just not the plant manager, it's not just the operator, it's not just what the nutritionists require or the animal require, but everything needs to work together to make sure the animal is getting the best performance, the best outcome from the feed meal that they can have, from the feed that they are being fed. Okay, so we need to make sure that we use the equipment and of course the nutrients, or the animal use the nutrients as possible. So these are what to monitor in a feed meal. So for sure the particle size, as I mentioned, the conditioning temperature, the moisture, that's really important for pellet quality and commercial yield. PDI fines, that's one indicator that we can look into that for, of course, it's the basic one for pellet quality. Final feed moisture, that needs to attend what the nutritionists work. So if the nutritionists formulate for 12% moisture, that's what needs to be your final feed. If it's 11.5, that's what needs to be. So the final feed moisture needs to attend what the nutritionist. We don't want to dilute the nutrients, but also we don't want to lose or have a shrinkage issue because we are sending feed to dry to the customer. And then that's just the improvements that we can have from when you're using, optimizing the process, right? So you can improve pellet quality, animal performance, etc. And then just the takeaway message. So feed efficiency is not only formulated, it's engineered through the process, right? So that's, like, again, is not just the nutritionist formulation, but also how the feed meal is producing that feed, how the feed meal are putting those points into practice. Condition is one of the most powerful levers for digestibility and pellet quality. So target particle size distribution, not only average size, and also need to be adapted to the species. As I mentioned, poultry layers one size, swine other size, and ruminants, of course, other size. Pellet quality is a KPI that reflects process stability, not the full object of its own. So pellet quality is one of the indicators, but it's not the only one, and it's not by itself. So it's a group of information, group of KPIs that we need to make sure that we are getting access. And sustained gains come from management disciplines, standard, KPIs, ownership, and fast correction. So make sure that we monitor, we make the adjustments, we change what we need to change, and that really bring that result. So for just to last phrase again, is not buy more, is use better what we already have available into the feed meal that we have available. So thank you for listening. Thank you very much.
Thank you so much. A round of applause for Mr. Antoniel. We appreciate, indeed, that was a wonderful presentation.